During the late 1960s, the aviation industry was experiencing a moment of radical transformation. While giants like Boeing and McDonnell Douglas were consolidating their presence in the commercial segment, Lockheed, traditionally focused on military projects, glimpsed a unique opportunity to diversify its business. The California-based company was about to embark on one of the most audacious adventures in modern civil aviation. But what was to come would be much more than a simple aircraft project. It would be a true technological revolution that would test the limits of aeronautical engineering.
If you're also passionate about the world of aviation, consider subscribing to the channel and supporting our team.
The project took concrete form in '66 when American Airlines expressed interest in a wide-body jet equipped with 3 engines, specifically designed for high-density transcontinental and intercontinental operations. Although the airline subsequently directed its preference to other options, the seed of innovation had already been planted in the minds of Lockheed engineers. Under the visionary leadership of Charles C. Wagner, the technical team established a clear objective: to develop an aircraft capable of directly rivaling the DC-10 from McDonnell Douglas and Boeing's imposing 747. The selected name, TriStar, perfectly symbolized the company's ambitions to create a cutting-edge trijet that would mark a new era in commercial aviation. But the true magnitude of this endeavor, however, would only be understood when the first prototypes began to take shape, revealing innovations that would forever transform the flying experience. The L-1011 TriStar immediately distinguished itself by incorporating revolutionary technologies that were decades ahead of their time. Its sophisticated aerodynamic design was complemented by the choice of the Rolls-Royce RB211 engine, a true work of art in British engineering. This selection represented a high-risk strategic bet. The RB211 promised to reduce fuel consumption by approximately 15% compared to conventional engines of the era, while operating with noise levels 20 decibels lower than existing standards. The TriStar's innovative 3-engine configuration included impressive technical specifications. 2 Rolls-Royce RB211-22B engines mounted under the wings, each generating 42,000 pounds of thrust, and a third engine integrated into the rear fuselage through an extremely sophisticated internal air duct system. This unique architecture allowed the aircraft to maintain exceptional stability even in adverse conditions, with the capability to continue operating safely even with the complete failure of one engine. The TriStar's automated flight control system represented a quantum leap in commercial aviation. The aircraft was pioneering in incorporating automatic landing systems in regular commercial operations, using a Delco Carousel 4 central computer that coordinated more than 800 automated functions simultaneously. But these extraordinary innovations would bring with them technical and financial challenges that no one could have foreseen. The construction phase officially began in 1968, establishing ambitious production goals and schedules that challenged industry standards. The first prototype completed its assembly on November 16, 1970, representing the culmination of investments that initially totaled $1.5 billion, equivalent to approximately $12 billion in current values, considering accumulated inflation. The TriStar's final technical specifications were impressive in their sophistication: fuselage measuring 177.7 feet in length, wingspan of 164.3 feet, a height of 55.4 feet, and maximum takeoff weight of 509,840 pounds. The pressurized cabin maintained an equivalent altitude of only 5,905 feet, even when flying at 41,000 feet altitude, providing incomparable comfort to passengers through a climate control system that completely renewed the internal air every 2 to 3 minutes. The internal configuration offered exceptional flexibility. In pure economy class, it could accommodate up to 400 passengers in high-density configuration, while typical mixed layouts carried between 256 and 300 passengers, depending on the proportion between business and economy classes. Economy seats offered 33.9 inches of legroom, 10% superior to the standard of the era, while windows were 30% larger than those of direct competitors. However, behind this facade of technical success, financial and operational storms were beginning to form on the horizon. The inaugural commercial flight took place on April 26, 1972, when Eastern Airlines proudly received its first TriStar unit. Eastern, recognized for its tradition of innovation and prioritizing passenger experience, decisively bet on the aircraft's potential, formalizing an initial order of 50 units. The established unit price was $23 million per aircraft, approximately $165 million in updated values, positioning the TriStar among the most expensive commercial aircraft in its category. During the initial years of operation, the L-1011 TriStar gained unanimous recognition from specialized critics and operating airlines. Its operational performance exceeded expectations. Cruising speed of 604 miles per hour, service ceiling of 42,000 feet, and range varying between 2,735 miles in initial versions up to 4,605 miles in the L-1011 500 model. Fuel consumption, although initially estimated at 1.06 to 1.18 gallons per passenger per 100 miles, in practice demonstrated variations between 0.9 and 1.23 gallons depending on load configuration, weather conditions, and flight profile used. Between 70 and 84, Lockheed's production line completed 250 TriStar units, distributed to prestigious international airlines including British Airways, TWA, Delta Airlines, Cathay Pacific, All Nippon Airways, and Saudi Arabian Airlines. Each operator developed specific configurations adapted to their routes. British Airways used the -500 model for transatlantic routes, while Delta preferred versions optimized for the American domestic market. However, even with this enthusiastic market reception, structural problems were beginning to undermine the aircraft. Despite the technical brilliance and positive initial acceptance, the L-1011 TriStar project faced a cascading series of obstacles that transformed the dream into a financial nightmare. The RB211 engine, the central piece of the aircraft's value proposition, became the epicenter of an unprecedented crisis in the aviation industry. Development by Rolls-Royce proved to be exponentially more complex and expensive than initial projections. The carbon fiber fan blade technology, revolutionary for the time, presented structural failures during certification tests, forcing a complete redesign that used titanium blades. This process not only delayed the schedule by 18 months, but raised the engine development costs from £150 million to more than £400 million. The crisis reached catastrophic proportions when Rolls-Royce, unable to absorb the growing costs, declared technical bankruptcy in February 1971. The British government, recognizing the strategic implications, proceeded with emergency nationalization of the company, investing an additional £250 million to keep the RB211 program operational. But the effects of this turbulence would extend far beyond technical issues, threatening the very commercial viability of the TriStar. The TriStar's innovative three-engine configuration, especially the rear engine integration, presented engineering complexities that exceeded all initial estimates. Unlike the DC-10, which used a simpler external mounting for the tail engine, the TriStar incorporated an internal S-shaped air duct system that conducted airflow through the fuselage to the engine. This ingenious solution, although technically superior in terms of aerodynamic efficiency and noise reduction, multiplied manufacturing and maintenance costs. The internal duct system required manufacturing tolerances 300% more precise than conventional standards, using specially developed titanium alloy that cost 15 times more than standard aeronautical aluminum. Additionally, rear-engine maintenance inspections required partial fuselage disassembly, resulting in maintenance times 40% higher compared to the DC-10. When finally delivered to Eastern Airlines in 1972, the TriStar demonstrated exceptional operational performance. The L-1011 500 version, optimized for long-range routes, achieved 4,605 miles of range, carrying 246 passengers, while earlier versions like the L-1011-1 operated up to 2,735 miles with maximum capacity of 400 passengers. The operational ceiling of 41,000 feet provided flexibility for route optimization and turbulence avoidance. But these technical achievements came too late to reverse the competitive disadvantage that had consolidated in the market. The competitive scenario had changed drastically during the TriStar's development delays. The McDonnell Douglas DC-10, launched commercially in August 1971, gained decisive temporal advantage of almost a year in the market. Both aircraft shared similar specifications: wide-body trijets with capacity between 250 and 380 passengers, but presented fundamentally different design philosophies. The DC-10 prioritized operational simplicity and cost-effectiveness, externally mounted rear engine, conventional control systems, and structure optimized for ease of maintenance. Its average fuel consumption of 0.99 gallons per passenger per 100 miles marginally exceeded the TriStar, while acquisition costs were approximately 15% lower, settling at $19.5 million per unit. In contrast, the TriStar offered incomparable technological sophistication: partial fly-by-wire control system, automatic landing capability in zero-visibility conditions, and superior cabin comfort levels through optimized pressurization and advanced acoustic isolation. Real operational consumption varied between 0.90 and 1.23 gallons per passenger per 100 miles, depending on flight conditions, with an overall average of 1.11 gallons. The TriStar's internal configuration provided superior flexibility. Two-class layouts comfortably accommodated 256 to 300 passengers, while high-density configurations reached 400 seats. Comparatively, the DC-10 typically operated with 270 to 380 passengers, prioritizing density over individual comfort. Paradoxically, even facing multiple fatal accidents documented in specialized series about the DC-10, airlines continued to prefer McDonnell Douglas's product for its superior economic value proposition. The L-1011 TriStar's commercial trajectory ended with numbers that reflected both its technical merits and market limitations. The 250 units produced represented a respectable achievement for a large aircraft, but remained below the estimated break-even point of 300 to 350 units necessary for sustainable financial viability. In 2024, only approximately 10 units remain in active service, primarily in specialized cargo operations, modified military transport, and aerial refueling missions. The last regular commercial passenger flight occurred in 2014, marking the definitive end of an era in commercial aviation. Gradual retirement began in the late 1990s when airlines began replacing their fleets with more efficient twin-engine aircraft like the Boeing 767 and Airbus A330. The TriStar's relatively high fuel consumption, a result of the three-engine configuration, became economically unsustainable in the face of progressive oil price increases and growing competitive pressures. Pilots and passengers who experienced the L-1011 invariably highlighted its exceptional maneuverability, incomparable stability, and comfort standards that remained unmatched for decades. The aircraft established new operational safety benchmarks, recording accident rates significantly below the industry average during its 42 years of commercial operation. Its history perfectly illustrates how pure innovation, no matter how brilliant, must balance with market realities, strategic timing, and operational execution to achieve lasting sustainability.